Hi, Andrea.
Joe.
Hello, everyone. Hello, everyone. Hi,
Good
Andrea.
morning.
How you
Good
doing?
morning.
Good morning.
Hi, Joe, and hello, everyone.
Good morning.
My name is Andrea Guajardo. Today will be your course moderator, and we would like to welcome you to the Big Data and Artificial Intelligence for Impact course that Joe Gilbert will be delivering for you today. This is a course in partnership between the ITU and the GSMA. This course will be delivered during 2 days for 2 hours each day, today and tomorrow. It will be delivered by Joe Gilbert. I would like to introduce you to her. Joe, please, if you could introduce yourself, please, I will be very grateful.
Sure, absolutely. Hello, everybody. Yeah, so as Andrea says, my name is Jo Gilbert, and I've worked at the GSMA for around 10 years now. I'm in the technology department within the GSMA, and I've spent a couple of years during that period working on the mobile big data analytics and AI projects. And I'm really delighted to be here with you today and tomorrow to introduce you to the topic and run through the course. So thanks, everybody, for joining. I'm looking forward to the next 2 hours today and 2 hours tomorrow.
Yes, thank you very much, Joe. So also I would like just to give you some admin information. So it will be great if you could, during the presentation, keep your microphones muted. In case you have any questions or comments, you can raise your hand, and then, or you can type any questions or comments in the chat space. I understand, Joe, that you will be presenting your slides, right, using deck, and also you will be having some activities as well with the
We will. There'll be some quizzes, some little quizzes towards the end. Given the time frame, we don't have time for a breakout activity, but we'll have some quizzes, and when we get to that, we'll talk about how people can get involved and provide their answers. So yeah, that will be. I think there are 2 parts in the 2 hours today where we'll do that.
Yeah. So that. Oh, sorry, I will mute. So yeah, so I was telling you, it'd be very important if you can keep your microphones. And if you have any questions or comments during the presentation, you can raise your hands or type in the chat space, and we will have some activities as well for you to participate. But Joe will be indicating you when that is going to happen and give you all the instructions. So if you don't have any questions so far, we would like to start, and of course we'll give you a warm welcome, and we hope you enjoy this course. Just one thing before we start, in order to receive your course certificate, you need to attend the course during these 2 days, and there will be a quiz, a very short quiz that you have to answer, that is in the dashboard of the course, and you need to answer it when the course finishes. So you will have around 2 days to answer that or the quiz as well. And after that, you will receive your course certificate. So with that, I think we have shared all the information with you, and we hope you enjoy the course. If you have any questions, you can just write anything in the chat space. And Joe, please, the floor is yours.
Fantastic, thank you. Can I just check that you can see the slides okay? Are they displaying on the screen? Wonderful.
Yes,
great.
Yes.
Fabulous. Lovely. Oh, question from Jenny. Was that a question before we began?
No, loud and clear.
Wonderful. Okay, fabulous. Thank you so much. Great, and thank you, Andrea. Lovely. So yeah, let's begin then. So first of all, welcome to this Big Data Analytics and Artificial Intelligence for Impact course brought to you by the GSMA Capacity Building team. If we move on to the first slide, we can go through the objectives for today. So during this course, we will be exploring the different ways in which mobile data analytics and artificial intelligence, or AI, can be leveraged to realise sustainable impact in a variety of different situations. So after defining what mobile data analytics and AI mean, we'll have a look at some examples of how they can be used in the real world to deliver some social good. And after that, we'll examine how the tools function in practice, along with the different business models that exist in order to be able to support projects that use them. And then finally, we will examine the policies, regulations and standards that can help drive the ethical use of mobile data analytics and AI, because obviously it's a critical element. And we'll provide some guidance on how the implementation of sustainable solutions can be used and also respect citizens' privacy. So they're the course objectives. So if I go to the next slide, I can show you how the course is structured. So it's broken down into 4 sections. Today we'll be covering sections 1 and 2, and tomorrow we'll be covering sections 3 and 4. So today will be around understanding what big data is, what AI is, and mobile big data analytics and sustainable impact. So that's what we'll look at first today. And then after that, we'll look at section 2, which is some examples. And we've got some examples about how mobile big data can be used to address infectious diseases, natural disasters, air pollution, and climate-driven migration. And then tomorrow we'll look at the foundations and principles. So the foundations is around how raw data is processed and how we can apply AI techniques. We'll look at some of the stakeholders that are involved in these kinds of projects. And then, as mentioned, we'll also be looking at the sustainable business models. And then finally tomorrow, we'll be looking at 2 key areas, the policy and regulatory considerations and also ethical AI. And then, of course, there'll be a course summary. So as Andrea said, if you do have any questions, please do ask as we go along. There is actually a question already about whether the presentations will be made available. I believe, yes, they will be after the course. I believe so, Sanjay. So hopefully they will be with you. Andrea will let us know if there's anything different there, but we will be able to share those. Okay, let's move on then with today's content. So first of all, we'll be looking at the understanding section. So what is big data? What is AI? And what is it useful for? And then also, how can big data be used for sustainable impact? Great. Okay, so let's start at the beginning then. So every day, mobile networks generate an enormous volume of data just as a result of the normal use of the phone service. So every time you're travelling around, your phone is connecting to the network. You'll make telephone calls, you may send and receive text messages or use data messaging service or the internet. And all of that time data is being collected behind the scenes in order to be able to provide billing and that kind of thing. So by combining this data that's collected with other sources of information and then analysing patterns and flows, unique insights and powerful support tools can be developed. So this data-driven output can assist decision-making across a wide range of problems, from mitigating pollution to determining how to respond to a natural disaster or an epidemic. So as we've mentioned, in this course, we're going to examine how that can be achieved. So we'll look at how the data is gathered, how it can be analysed, and what needs to be considered when we're analysing this data, and then understand the types of decisions that can be taken as a result of the analysis and the sort of business models that can help make that happen. So I guess the first question is, what is big data? Well, big data is a relatively new phrase and it has got many definitions and it can often be used as a bit of a catch-all term. to refer to many things. But in this course, we're really going to illustrate how it can be used to deal with development challenges in a sustainable way. So firstly, it's important to note that big data is natively digital. That's the term, natively digital. And that means that it doesn't need to be re-recorded or encoded or converted because it's ready to be fed into an analytics pipeline at the point of collection. So as I mentioned, and we've got 3 examples here, the first is in the mobile network. So every time that you make a call or the phone just connects to the network, so it's able to route calls through to you, all of that data needs to be collected as a way of delivering the service to you. So that data is collected natively, not purposefully. It's just natively collected, and that's what's available from the mobile network. Similarly, from the banking sector, so every time you use a ATM machine, or you perhaps use a card or a mobile financial service at a store or on the internet, just the nature of the service means that that data is recorded. So that, again, it's natively digital. And then finally, of course, the internet. So if you think about every time you go to a search engine like Google and you put a search in, that data is stored, collected. Okay, so there are a number of characteristics of big data. And the first thing that we look at is the 4 V's that make up big data. So the first one is volume, then velocity, then variety, and then veracity. And we're going to be looking at each of these terms on the next few slides. But then the other characteristic, which isn't a V, is organic. And this organic is referring to the digitally native data. So it's organically generated as a side effect of the service that is being delivered. So let's have a little look at each one of these in turn. So first of all, what is big data? Well, in terms of volume and velocity, big data is big. It takes up lots of volume. So, for example, if we're thinking about the space on disks where it might be saved, and it updates and it expands rapidly, this means that powerful computing resources and specialised software and techniques are required to process and analyse it because it's a huge volume. It's way bigger than it could ever fit on a spreadsheet. And the velocity of big data is also incredibly fast. So if you think about the mobile network, commonly they process billions of events every day and possess the infrastructure to manage and organise this amount of traffic and the data that it generates. So if you think about your capital city, for example, if you think about everybody in that, most people have at least one mobile phone, and each of those will be generating data every minute, every hour, every day. So huge volumes and expanding in terms of the volume of data very rapidly. Okay, the next V is about variety. And this refers to the fact that big data is made up from different types of data that follow different structures and formats. So these need to be managed separately with the ability to combine them when appropriate. So in mobile networks, there are broadly 3 types of data. The first is event data, which provides time-stamped locations of specific customers. So, for example, if you make a telephone call, your call connects to a network mast. So we're able to, so what is recorded is the mast that you connected to, plus the time that you made the outgoing call. The second is about network topology, which gives us geographical location. So basically we understand the geographical location of the tower that your core connects to. And the third is the customer profile data, which provides an enriched picture of the type of people using the network. So each of these big data types has different natural structures and and processing systems. And event data sits in stores or data streaming platforms, for example. Network topology data has a strong geographical component, so sometimes needs a geographic information system or a GIS capability. And customer data is tabular and it's relatively static, so it's not updated as often. And so this may be, for example, the type of tariff that you're on, that kind of thing. So this type of data sits in a relational database management system. So I think the important thing to summarise when it comes to variety is we collect different types of data in different formats that may need to be stored in different types of systems. So that's one of the things that we need to consider when we're looking at working with this kind of data. Okay, so the next V is about veracity, and this is all about how trustworthy the data is. So it's possible to find many answers in big data, but to do this, it's really crucial that we ask the right questions. So the complexity of the systems that generate big data can hide surprising variations. You may have heard of the term noise, or sources of bias or error. So when we try to use data to find out how many people have made a call in a particular place in a particular time period, there are many sources of noise that need to be understood, quantified and mitigated for the data to be used safely and reliably. So, for example, if we ask the question, how many people made a call in a particular region on a certain day, what we're really asking is how many SIM cards made calls. So the SIM card might be shared between multiple users, or an individual might have multiple SIM cards with different carriers. So we need to understand the data that we are working with in order to be able to truly answer the questions. So that's what we mean by veracity. Additionally, there might also be some biases in the customer base versus the wider population. For example, network issues might lead to dropped or duplicated traffic. Cell towers and base stations are given IDs in the network, which might be reassigned when the network's upgraded, giving inconsistencies in the location associated with the event. So basically, things might change in the network that, unless they're accurately recorded and understood, it might bias or it might bias the data and reduce the veracity of that data. Similarly, the phone numbers associated with SIM cards are limited and they're sometimes reused when a subscription is cancelled. So we need to take that into account and understand whether numbers belong to certain people or not. And in addition, if you live or work on the edge of two cell tower coverages and it can hand over between the two, it might show an inconsistency about potential home locations, for example. So there are lots of things in the data that you need to understand in order to be able to mitigate before, to ensure that you're answering the right questions with the data that you've got, or the data is useful for you to be able to answer the questions that you're trying to answer. Okay, so that was the 4 V's, and then we also had the O, which is the organic, and we've kind of already touched on this already, but this data is data that is found through passively generated through normal and natural behaviours. So the important thing about the organic element or the digitally native element is that it's not recorded on request, or it isn't even explicitly, there's no explicit intent to collect that kind of data. It's very different from the data that's obtained from surveys, for example, which are explicitly designed to deliver answers to specific questions. So we have a particular example here when we are looking at the difference between organic and designed data. So if, for example, we wanted to find out about rice consumption in a particular family, If you wanted to find out how much rice a typical family has bought when they've been shopping each week, you could design a really detailed survey in the form of a questionnaire, for example, and ask a sample of people to fill it out. And the response to the survey would let you know very specifically how much rice, how many bags of rice each family bought from the store that week, or from across a number of stores each week. But what that survey wouldn't tell you is the amount of pasta that the families have brought, because that question wasn't asked. So if you wanted to find out the following week about pasta purchases, then you'd need to design and run a second survey. So to compare that to another sort of data that every supermarket has available to it, and this is a huge stream of data about purchases of all types. So if instead of developing the survey, we use the passive data that was collected at the supermarket, we would be able to understand, because of the purchases going through the store tills or through the online shopping, we would be able to understand all of the different types of purchases. So how much rice has been purchased, how much pasta has been purchased, or any other, food items. So once you have that native digital data from the supermarket store, you have a potential to interrogate the data to ask lots of different questions. And that could, of course, if you'd have done your survey in a particular location, you could have some restrictions there. However, if you had access to the supermarket data, you could potentially look at different patterns of purchasing across different regions. So, your opportunities do grow there. Okay, we have one question. Just bear with me a second. I'll make sure I can read that. What happens if you have incomplete data when we're dealing with big data? That is a great question. And I think there are potentially two ways. Well, I say two ways to deal with that. One of the things we talk about later on when we talk about the stakeholders is the working with the data scientists and the people that really fully understand the data. So, for example, in mobile network data, we might see that we might have some incomplete data if there has been some work on the network and one network was not collecting one of the cell towers was not available, so we weren't collecting any data there. And with the knowledge and the expertise of the network team and the data scientists, often they can apply techniques in order to be able to, I'm going to say, smooth out the data. So look at perhaps previous activities to try and correct the data, looking at the veracity that way. So in some cases, if you have very incomplete data, it may be that you can't answer the question that you're particularly trying to ask, but sometimes you can deploy some techniques in order to address that. The important thing to think through, though, is having people that fully understand the data so they can be aware if there is any incompleteness. I hope that answers the question. Okay, I heard a thing, so hopefully I haven't missed any other questions there. Oh, it has. Fabulous. Thank you. Thank you very much. Okay. So to just summarise on this slide, so I was just saying that one of the things that once you have this passive data from the supermarket, it enables you not only to understand how much rice was bought, but also how much of all of the different foodstuffs were bought. And then also you can look at patterns in terms of location. For example, is more pasta bought in one area and more rice bought in the other area, for example. So one of the features of big data is it opens up unique insights to otherwise invisible patterns. So without individual biases associated with the deliberate data collection, it can open up a huge opportunity. So because you're not going into it thinking, I need only to understand how much rice has been bought, having all of that data there available, it means you can delve in to ask lots of different questions. But again, understanding the data is important. Okay, so to summarise then on what is big data. So we've covered these 6 points. So first of all, big data is natively digital, so it's collected passively. There are huge data sets. It can change rapidly, so new data is added often in the case of mobile network data. It's a combination of both structured and unstructured data, so you need to think about how that is stored and how it can be combined. It contains bias and error, and I think with every set of data we need to assume that there's some bias and there's some error in there that needs to be processed. And actually, just to add to the question just asked, tomorrow in the first part of the session we will go through the process of cleaning and managing the data, so there may be some more answers in there as well. And then the final one is that big data is around patterns that can be found without the intention to collect data. So okay, so that is the first part of the session. So let me get, we're already at a quick quiz, so that's good. Right, let's see if this works. So if you look at the top of your screen, you can see, you can put a thumbs up sign. Hang on, let me tell you what it's called because I can't see. In the reactions, so just at the top up here somewhere, there's a reactions and you can do a thumbs up. So I'll read them out and please do give a thumbs up if you agree with these. So which of the following V words are used to help define big data? The first one, volume. Is that a feature of big data? If I can see any. No thumbs up? Okay, so volume is a feature of big data. So there is a large volume of data, lots and lots and lots of records are created. So the next, I can see people answering the chat. Thank you. So the next is vague. So is big data vague? Is that one of the features? Yeah, I can see a no. Yeah, the big data isn't vague. Is one of the features of big data velocity? Pretty chance. So velocity. Yes. Lovely. Thank you. This is working nicely. So yeah, velocity, which means that it's generating lots of data. It's rapidly changing. Sorry. Now the next one, variant. Is variant or variety? There's neither or question. So variant is not a feature of big data, but variety, lots of different types. Variety, yeah, thank you, Feta. Variety is a feature. So different types of data that might be stored in different, I've lost the word, different storage types. So for example, geographic information might be in a GIS system, a geographical information system, but we might have data about the customer in a sort of standard table format. So we need to great. Oh, and Jenny's jumping ahead. Yeah, volcano. Nope, you're absolutely right. Volcano is not a feature of big data, thank goodness. Veracity is an example of one of the features of big data. So getting to the truth of it, and then finally, video is a type of data, but it's not a feature of big data. So wonderful. Thank you very much. Thanks for your engagement on that. That's great. Cool. Okay, let me move to the next. Right, this is the last question. So which is true about big data? So the first one, it is natively digital. Yeah, we've got an A there coming in. Lovely, thank you. That is true. It is natively digital. It consists of huge data sets. Yeah. It's huge data sets. The data changes rapidly. It contains structured and unstructured data. I'm going through this. I'm going through quick, so I'm going faster than you can type. Thank you. And then E, it contains bias and error. So I think we know where we're going with this, don't we? So is F correct? All of the above. Yes. Thanks, Krishna. Yes, it is. And yeah, thank you, Feta and everybody. Fabulous. Thank you. All of the above. Great. Okay. So hopefully that all makes sense. I think we're moving to the next section now around AI. But before I do that, any questions about the big data part before we move on? No, that sounds great. If no questions, but please do jump in with any questions as we go. So let's look at the next section then now, which is about AI. So we'll just spend a short time looking at a related idea of big data, which is that of artificial intelligence, or AI as we know it. So we have a question. In the case for minority groups in big data-driven social research based on development studies, is bias like demographic voids are common in big data? Potentially, yes. We'll talk about this at the beginning of tomorrow, but there is a possibility, for example, in some communities we might see that phone ownership may be owned by more males than more females, or in some societies maybe and the male might own all the phone contracts, but the end users of the device of the actual phone numbers are women, and that's one example. So looking at gender ownership of devices, and there are ways that we can take a look at that. Similarly, in terms of population numbers and that kind of thing. So this is again where it's helpful to be able to understand the context of the region that you're looking at the data and understanding the network data. And then there are some techniques that you can use to make the data more representative for the question that you're trying to answer. So that is so that is absolutely a risk of bias. So again, understanding the data that you're working with and having the tools to be able to mitigate for that are important, and often the mobile network operators are the best place to be able to support with how to address that data. Okay. What about data collection? Data collect from IoT. This great question. So yes, absolutely. When we're talking about veracity of the data, one of the things that we may want to do, if, for example, one of the key, we will talk about this as we move on to the later section today, but one of the key features of mobile big data is to be able to look for patterns in population movement or population density. So that's some of the really most well known and most well used way that we can use mobile big data. But it's absolutely true that IoT data, which is the Internet of Things, is when your devices or machinery might have a SIM card in it and maybe using the mobile network in order to be able to send messages backwards and forth. So, for example, a vending machine on a train station that's selling bottles of water might have a SIM card in it, and it might be reporting back to the warehouse when it's running low on water and it needs somebody to come and fill up the water. So again, this is around removing bias. So one of the key elements of preparing the data in order to be able to use it to generate insights is to take away any irrelevant data. And the IoT data would be that kind of data that you would want to strip out from the raw data before you started to process it. So yeah, great question about IoT. Okay, so happy to move on to AI.
Yeah.
Lovely, thank you. Okay, great. Okay, lovely. Okay, so we're talking about AI then. So AI is the ability of a machine or a computer to emulate human tasks through learning and automation. And AI algorithms take decisions as a consequence of the application of advanced analytic techniques, and they may be applied in combination with automated advanced loops, for example, to solve problems. So complex maths, complex computing. It's a technology very familiar to mobile network operators because they've been using it for a while to do things like detect fraud and in providing customer support. So I don't know if anybody has recently tried to get any customer service support on the web, on a website, and they have been looked after by a chat bot to answer very simple questions. So that's often AI that's kind of predicting what your questions might be. And the other way that mobile networks use it is to optimize the mobile network, so to make sure that it's running efficiently. And more recently, AI has been used to look at how the network could be save more energy. So that's another way that AI is currently being used. So AI is good at performing really well-defined tasks on large amounts of data, and it can learn patterns and it can detect similarities and anomalies. It's good at forming groups of similar items. And it's good at identifying the most meaningful signals. So it can work through the data and, again, look for patterns and similarities, look for things that don't fit in, so those anomalies, and it's good at grouping things. So, for example, if it had lots of pictures of cats and lots of pictures of dogs, it's quite good at being able to sort them into groups of cats and groups of dogs. However, AI is not great for everything, and there's some things that it's really not good at and we shouldn't try and use it for. So the first is it's not very good at drawing information from a wider context. So anything that's not directly represented in the data available to it, it is not able to generate, or infer. It isn't very good at inference or causations. It can only look for patterns, so it can't infer why something's happened. It can only see the pattern that's in that data. And also, it's not very good at dealing with just very low volumes of data. It needs big data in order to be able to function. And also, going back to some of the questions that we're talking about, AI is not good at filtering out bias. So this has to be done prior to applying any AI by a data scientist and specialists that understand the data that they're working on. So that's really critical. So AI can only really work on once you really know the data that you're dealing with. However, as I've said, it can be really useful when analysing patterns that will lead to social good. And later on this morning, we're going to look at some specific examples. Yeah, but without AI, certain insights wouldn't be possible, but it's only applicable in certain circumstances and certain cases. But it is fantastic when you're able to use it. Okay, so let's have a little bit of a deeper dive then into the AI. So obviously we couldn't cover everything today, and the field of AI is very large and very complex. And I put my hand up to say that I am not a data scientist either. My background is not data science, so I can give an introduction to it. But it's often described as being comprised of a mixture of technologies. So you may have heard of machine learning and neural networks. They're the kind of technologies that it can use. Subfields. So, for example, natural language processing and computer vision. I love the example of computer vision that an AI that's used in factories that are producing white goods like fridge freezers. And you can use the computer vision and AI for them to scan the side of the fridge to see if there are any scrapes or scratches or defects on the side of it. So historically, they'd have to have a human looking at each individual one, but now a computer vision robot can use the camera to scan and AI to identify if there are any anomalies on the side or the front that can then be addressed to see if it's been in some way damaged. And then finally, the third one is applications. And we've already mentioned chatbots, which is an example, but also autonomous vehicles, whether that be, autonomous cars or autonomous drones, or in factories, autonomous mobile robots, for example, or another example of how AI can be used. Okay. So, I've probably jumped ahead here a little bit, but let's go through these. So in terms of AI applications, first of all, we talked about autonomous vehicles. So we know about driverless cars and drones, as I've just mentioned. And so these are vehicles that can navigate through a physical space and perform tasks without human input. So they can use cameras and sensors to ensure that they're not going to bump into a person or an object. Chatbots, as we've already talked about, and virtual agents. So these are the digital tools for stimulating conversation, and they're usually designed for specific tasks. So, for example, if you want to call, if you want to go online to just check the balance of an account, or doing some sort of triage for problems, chatbots are quite good for that. The next is medical diagnostics. So helping to determine the cause of a medical complaint, usually from images or from descriptions of symptoms, as well as patient information. So I think one of the examples is how AI can be used to look at many medical images to identify where there may be potentially anomalies, indicating a health problem in an individual, and then they can flag them as potentially anomalous, and then a human doctor can take a look to identify if there is actually a problem. Excuse me. And the next one is fraud detection. So this is about detecting and mitigating fraudulent behaviour, either aimed at a company or its customers. So looking for unusual transactions, for example, in an unusual place or an unusual store, or for an unusual amount. And then finally, cybersecurity. So around detecting and mitigating attempts to gain unauthorised access to digital assets. So there's some of the examples of AI. And then we can talk a little bit more about some of the AI fields. So the first is natural language processing. So this is the study of computer understanding and processing human language. This includes a semantic understanding of a text. So an AI can be used to read some text or listen to some text and understand what the semantics of that text or language is. The next, as I've already mentioned, is computer vision. So this is about processing and extracting information from images and videos. And it includes object detection and recognition. Facial recognition actually is another one, and 3D environment reconstruction is another example of computer vision. And as I've mentioned, detecting for defects on the production line, things like that. And the next one is robotics. So this is controlling a physical device and enable it to automatically perform a series of actions. AI can support with that. And then finally, optimization. So selecting the best solution to a mathematically defined problems and from a range of options. So one of the examples I quite like for optimization is around bin collection services. So if you have sensors on refuge bins around a city, that tells you how full the bin is. You can collect in that data and then use an AI algorithm to identify the most efficient route through the city in order to collect only the bins that you need to collect. So that's a really nice example of how AI can be used for optimization and efficiency. Okay. Right, and then finally for the AIs, some of the techniques which we've touched on already. So machine learning. So this generally refers to a set of techniques involving learning patterns from data and using the patterns to make decisions or predictions. So classic machine learning problems include classification, so determining whether something belongs to a specific category. So for example, male or female, or cats or dogs, as I mentioned earlier. The next one is regression, which is about predicting a quantity, like predicting a temperature or predicting the number of people on a specific train. That's another example of machine learning. And then finally, clustering, which is grouping things collecting things into groups based on, patterns or similarities. So that's machine learning. And the next one is neural networks and deep learning. So this is a specific approach in the machine learning lexicon that uses mathematical networks inspired by the function of living brains. So this is definitely for a data scientist to be able to explain the ins and outs, because I'm not an expert on the neural networks and deep learning part of things, but fascinating and amazing that it's able to use these very complex mathematical networks in order to deliver output. The next is about symbolic logic, and that's the use of logic statements and predicates how a computer can perform reasoning. So one of the examples, and I have to think carefully about this because I sometimes get it the wrong way around. So symbolic logic, an example of that would be that all cars are vehicles, and I drive a car, therefore I drive a vehicle. So it's the logic of identifying something based on its based on reasoning. Based on reasoning. So all cars are vehicles, and I drive a car, therefore I must drive a vehicle. Okay, and then finally, the last one is Bayesian inference, and this is really about probability. So it's the probabilistic approach that provides estimates of the likelihood of something happening based on evidence. Okay, so they're the techniques that we use in AI. So we are, we're doing great for time, which is fantastic. We are now at the quiz. So the answer to these are either good or bad. So can you let me know if the chat works for you? Let's carry on using the chat. That would be great. So can you let me know, is AI good or bad at filtering out biases? Any answers? I'll give a hint. So if you remember, bad. We've got a couple of bads. Thank you. Fantastic. Yes, yeah. It's bad. So basically, as we talked about with big data, you need to really filter out. You need to filter out your bias before you can apply your AI techniques to your big data. The next is AI good or bad at performing defined tasks on large sets of data? Yeah, thank you, Naima. Good. Yeah, and Krishna and everybody's moving so quickly. So Viska, thank you. Brilliant, good. It's wonderful. Thank you, everybody. It's great at that. So large volumes of data and a defined task. AI is a great solution. So the next then is AI. Is it good at identifying meaningful signals? Meaningful signals. So maybe patterns and signals, and yeah. We're good. Yeah, it's good at doing that as well. So it's good at identifying patterns and signals. Fabulous. Then next, is AI good or bad at drawing information from a wider context? Is it good at understanding what's outside the data set? Yeah, thank you. Yeah, it's bad. So it can only work on the data that it's given, and it's not good at bringing in in fact, it's impossible for it to bring in context from elsewhere. Then last but one, is AI good or bad at tasks where there is limited data available? Yes, straight in there. Yeah, it's not good at that. It's bad. It needs large volumes of data. So AI makes the most of big data. When the data is limited, it's also limited. And then finally, is AI good or bad at learning patterns? Yeah, thanks, Naima. Yeah, and Bilal, yeah, and Jenny, yeah, wonderful. Thank you, everybody. What great stuff. It is great at that, learning patterns. And there we go. I thought there were 2 questions, but there are not. So how are we doing for time? I think we're doing okay. So yeah, the next is around sources of mobile data. So just to very quickly recap, we have talked a little bit about what big data is, and then what AI is and how AI can be used on big data. So before mobile data insights can be produced, the raw data needs to be collected. As we've talked about, that's collected passively. And the data used is generated as part of the normal operation of the network. And data about, which cell tower an operator's user is connected to. This is all the kind of data. So let's dive into this a little bit more, because we've briefly touched on it, but let's look at some of the examples of the sorts of raw data that are collected by the mobile network operator. So we've touched on this a little bit already. But the first is the identity data. So this is information such as the name, date of birth, and the national identifier. So that is a source of data, but bear in mind it's data usually of the person that has bought the SIM card or bought the contract or bought the device from the operator. The next is around subscription data. So this is information, everything about that subscription. So it will be the device number, the phone number, and the SIM card number. So every device has got a device number. So device number, phone number, or SIM card number. And then the next is the network usage data, or event data, as we call it. So this is information such as the telephone numbers that you've dialed, which websites have been visited, who's messaged who, when you've made a data connection, that kind of thing. And then finally, there's the network data, as we've already touched on. So this is data including the locations of the phone masts that are used, handover data. So if you imagine that if you're on a train or in a car or on the bus and you're moving from one geographical area to the next, you will move from one cell mast to the next cell mast. And then finally, the quality of service of information is also quite valuable from a network data perspective. So, for example, if a particular cell tower is out of action or is not fully functioning, then that might affect some of the data, the raw data that we start working with. Now that we've seen the sorts of data that is available to analyse, let's look at the types of data insight that's available. And so these can tell us a lot of things about the behaviour of people and properties of regions, and they can have a strong geographical component, as I kind of hinted at earlier on in this session. So there are three types of mobile big data insights. The first is the location and mobility. The next is around social networks. Now, this can sometimes cause a little bit of confusion. When we talk about social networks in the terms of the mobile network data, we're talking about people's connections to other people. Telephone calls, for example, between one person and another person, or as we will talk about this more, patterns in telephone calls between people in one region to people in another region. One of the things that we're going to touch on later is we never look at the individual's data. We always anonymize and aggregate the data in order to protect the privacy of the individuals, but we will cover that quite a lot as we move on. And then the final, of course, is economic indicators. So this could be in terms of the cost of people's bills, how much money people are spending on their mobile phones, or in some countries there are, of course, mobile money services. So data and information about that can give economic indicators, for example, in a particular region. Okay, so let me move to the next slide. So looking at in a little bit more detail at how this mobile data can be used. So as I've mentioned, we always anonymise the data. So once it's anonymised, so we don't see information about individuals, it can be used in many ways. So first, as I think I said earlier, location and mobility data is the most widely used, and it's the best understood, and it's the most generalisable between geographies. So this kind of data can help us to understand how populations are distributed in an area and how people move around between regions. And we can do that by seeing activity against particular cell towers. So we can look at just the density of people in particular regions, or we can see how they might move between one region or another. The next, as I've just mentioned, is around social networks. So we can look at things like contact frequencies between regions, and that might help us to understand how interconnected different regions are. And then finally, the economic indicators, and this can reveal information such as how much disposable income might people have, and this can help us to understand how financially secure different regions are and how much money is spent in each one. So that can help us with that kind of information. But as I say, the one that we tend to use the most is around location and mobility. Okay, so as I've mentioned, as we've kind of alluded to and we've covered in the we've kind of touched on in the Q&A so far, the data that's generated by the mobile in its raw form is not useful on its own. So if you look at the raw data, you will essentially see a really long list of meaningless letters and numbers. And so if you can see on the screen here, these are some examples of the records that the raw data that is created. On top of that, different network systems generate event data in different formats with different collections of fields. So this is data here that's been collected from one particular mobile network operator, one particular country, but it might be very different for a different operator in the same country. But generally, the fields include similar information, even if it's not in the same format. So it includes things like the sending and receiving phone numbers, the identifiers for part of the networks that handled the origin of the call and the recipient of the call. So if I'm currently in Yorkshire in the United Kingdom, so if I called somebody on this call now, the call record would identify where I originated the call, so in Yorkshire, and where that call was received. So perhaps Andrea in Brazil, perhaps. That's the kind of data that is collected. And this is where the mobile network operators come in order to be able to help to make sense of this data. So they're able to provide sophisticated processing and analytics to be able to realise the value of the big data and generate the actionable insights that we're going to cover in some use cases coming up. It's important to understand, though, that it's very complex and it's also very time consuming, and it requires substantial expertise to make sense of the data that's generated. So we have a question here. Those data are separated like for SMS call data. Yes, I think so. Each in the example, each of one of these examples refers to a single event. So, for example, it could be a telephone call from one person to another person, or it could be an SMS, or it could be data. Yeah, the data could be the internet, or it could be an application that uses the internet, like a messaging app, that kind of thing. So, obviously, for each type of event that it's recording, the data that would be collected would be slightly different. So, for example, with a telephone call, as well as the originating location and the originating number and the recipient location and recipient number, we'd also have the length of the telephone call, for example. But with an SMS, we wouldn't have the length of the call because it's just a single SMS transaction. So hopefully that makes sense. So if you can imagine, for every single event, if you just think about everybody that you know and everything that they do on their telephones, each one of those things creates an event, a CDR, it's called, or a call detail record, and it results in one line of data. So this goes back to the velocity of the data. So you can imagine if this was being added to as live as we were speaking, we'd just see the numbers kind of rolling up as new lines would be added every second. Many lines would be added every second for a particular country, for example. Okay, right. So next slide. Hopefully that answered the question. Let me know if not. In the meantime, I shall move on. So yeah, so just to recap on that, what we talked about is getting from that complicated raw data into something that's clean and usable, and then being able to apply it to give insights is quite a complex job, and the operators are able to support with this, but it does take time and effort to get to that place. Okay, so now we know a little bit more about the background. Let's talk a little bit about how it can be applied, and we're just about to move now into the second section, which talks about the use cases, but let's just set the scene for that for the end of this section one. So once the insights are generated by the operators, the decisions that they can influence can be really significant, and they can even help make decisions for those seeking to realise the UN Sustainable Development Goals. So the SDGs, as we are probably all very familiar with, are a universal call to action to end poverty, protect the planet, and ensure that people enjoy peace and prosperity. And in 2016, which, gosh, that was quite a while ago now, wasn't it? Oops, sorry. Moving my screen. In 2016, the mobile industry was the first to commit to the SDGs and opening up the possibilities for mobile operators to provide public agencies and non-governmental organisations, NGOs, with unique insights and powerful decision support tools. So the table, which I guess most of you will be quite familiar with, shows the types of Sustainable Development Goals, lists the Sustainable Development Goals as they exist. And then I think if I move to the next slide, oh no, coming up next. So I've got a video to show you in a moment, but on that previous slide, we've got all the Sustainable Development Goals, and on this slide here, this kind of groups them into the types of use cases that mobile data analytics can make possible from big data. So as you can see, they're grouped into cities and infrastructure, climate change and environment, managing disasters, health, citizen inclusion. And then below them, we've got a few examples of how mobile big data can be used. However, I won't go through that because I've got a video to show you now. I'm hoping that that's going to work. And then we'll move into section 2 where we can deep dive into a few of these. So let's move to the next one. There is supposed to be sound. Apologies if there is not sound. Okay, give me a second. I might need to work on that. Was there no sound for anybody? Yeah, apologies. Let me go back a slide and see if I can work that out. Oops, stop. Right. There's always one glitch, isn't there? Right, I'm just trying to work out what I need to change. That's very frustrating. Okay, let me
Yes, I'm trying to see as well.
Thanks, Andrea. I was just going to ask you if
maybe if you send me the link as well, I could try to play it.
Okay, that would be great. Give me 1 second. I think I'm sure that there is a setting in Teams that should play it, but I'm struggling a little bit. Right, so let me. Right. Sorry to keep you waiting, everyone. It's a great video, so it's worth playing, I think. Right, oops. There we go. Right, I'm going to just forward you a message, Andrea.
Mm-hmm.
And it's the link. So I'll check which slide number it is. It's slide number 28. So we can give that a go. But I have a feeling that there is something that I could probably change. If this doesn't work, we'll go straight through to the next section and we'll get it working ready for the start of tomorrow. So you can see it. That sounds like a good plan. So Yeah. But we'll just give that one go. Oh, hang on. Right. No, I thought I'd found something. Yes, I don't change my audio settings because then you'll probably not be able to hear me for the rest of the session, which make it complicated.
I think, Joe, when you click on share content, you can share, when you share your screen, there is also about audio.
Right,
Maybe
okay.
It's when you click on the share button, I think there is an option to...
yes. Wonderful. Thank you so much. Great. Okay, fingers crossed. Let me know if you don't hear it.
With governments, agencies and companies around the world.
I'll start at the beginning. Oops. Great. Okay. Right. From the beginning. Lovely. Thanks for your patience, everyone.
Mobile operators are working with governments, agencies and companies around the world, building solutions that leverage mobile big data to combat some of the world's greatest challenges. From fighting epidemics to combating pollution and responding to natural disasters, big data analytics is changing the game and is only just getting started. Mobile networks direct our calls, messages and data to devices around the globe. These events produce enormous data sets, recording which cell tower each device is connected to, capturing the approximate locations of all devices on a network. This is essential for the network operation, billing and other business purposes, but the data can be used for something much bigger. So how does it all work? It's a bit like recycling. Just like an empty plastic bottle is the result of consuming a drink, the data is a byproduct of using a mobile service, and in its raw form, it's difficult to use. It's also sensitive from a privacy perspective, and its use is governed by laws and regulations. It needs to be sorted, cleansed, filtered and combined with other data sets using expensive specialized equipment capable of handling very large volumes, along with plenty of care and expertise to turn it into something valuable. Operators take privacy seriously and engage in dialogue with regulators to protect it. They also understand the data their networks generate. By using the right algorithms and parameters, valuable signals can be picked up from these patterns. With careful processing to produce accurate results, it's possible to gain important actionable insights into human behavior. Grouping device locations over the whole subscriber base paints a picture of how a population is distributed around the network area. Monitoring how this changes over time reveals patterns of human mobility. When these patterns are combined with other data sets and fed into analytics pipelines using geospatial or statistical analysis, machine learning or artificial intelligence, they can support high-impact decision-making. For example, in India, GSMA and Airtel, working with the World Health Organization and ITU's Be Healthy, Be Mobile initiative, use mobile data to improve how they identify target areas for tuberculosis interventions. The project used aggregated data on habitual movements between areas, reflecting the way the disease spreads. This data was combined with population maps and TB incidence rates and analysed to identify regions for targeted interventions. In Europe and South America, Telefónica's data analysis unit, LUCA, used mobile data and advanced algorithms to estimate traffic levels across entire cities and combined this with weather and air quality data to predict air pollution, while Japan's KDDI is developing an information management platform using real-time maps of population density, traffic data from connected cars, along with IoT-connected sensor data on environmental conditions to guide emergency services during natural disasters. By using big data in the right way and working closely with global partners, the mobile industry is making a huge contribution to the Sustainable Development Goals and playing a key role in making the world a better place for all.
Fabulous. Great. Thanks everybody for bearing with us, and yeah, hopefully you found that valuable. Okay, yeah, so great. I think that was a great summary, and we're going to be diving into a few of those case studies that were just shown now for the latter 45 minutes of this session. But in summary for section 1, so the data generated by mobile activity is potentially powerful and can be used to inform decisions that have the ability to transform societies. However, the data on its own does not directly provide the answers. It's a raw material that can be processed and shaped by experts to provide something useful. And use of mobile big data requires skills and expertise, tools, and an understanding of AI, as well as knowledge of the particular data network in question. And only when the mobile data has been transformed into an actionable output can it be used to realise positive impact. So for the rest of this session, we'll be looking at some of that positive impact. And then, as I've mentioned, tomorrow, for the first half of the session, we'll talk a little bit more about what's involved with processing that data so we can get to the point where we have actionable insights. Okie doke, let me start at the beginning of section 2. Now's probably a good time to stop for a second to see if there are any questions. So looking at big data from a qualitative perspective, how many gigabyte size of data is needed so that we can know we're dealing with big data? Oh gosh, that is a difficult question. I'm not sure. I'm not really sure that I can answer that for a couple of reasons. I think it will depend on the type of data. So, for example, video data is going to be bigger than these core data records that we were looking at. So that the amount of information that you'll get in the same number of gigabytes of core data record compared to video data might be different. So I'd look at the source of the data and work with a data scientist to see if there's enough volume to answer the question that you're trying to achieve. Yes. Okay, is that somebody replying back to me, or if not, could you go on to mute? I can hear a little bit of background noise. I think it's gone now. Yeah, does that make sense? Hopefully. So it needs to be big, but I don't think we can. I think Jenny says it's difficult to put a size on it. It depends what the data is and what you're trying to achieve from the data that you're looking at. Okay, hopefully that answers. Okay, so let's move on to section 2, second part of today. Great. To understand the power and potential of mobile data analytics and AI for sustainable impact, we're going to have a little look at some of the analytics in action. So we've only got around 40 minutes left. So let's I'll try and I'll go through some of these faster than others because they're repeated in the video. But first of all, let's just set the scene. Mobile big data analytics and artificial intelligence can be used to mitigate and counteract the impact of things like infectious diseases, disasters, air pollution and climate change. And it can also be used to inform inclusive policies that it could improve the welfare of citizens in the population, for example. And the use cases that we feature in this section explore data and AI products and services that mobile network operators can provide in response to these challenges. And they feature examples that address one or more of the United Nations Sustainable Development Goals. But yeah, it's important to say that they do not represent the full range of potential with the use of mobile data and analytics and AI. And if we had more time, we'd could run an activity to look at how we might address these things. But hopefully, as we go through these, this might sort of spark some ideas about how the data could be used for some of the challenges that you're aware of or would like to address. So hopefully we'll look at 5 examples if we get time for them all. The first is around aggregated mobility to predict infectious disease hotspots. And the next is about identifying mobile data insights to plan interventions to limit the spread of disease. So the first is about identifying hotspots, the second is about limiting spread. The third one is about responding quickly and effectively to natural disasters. And the fourth is about using mobile data to predict air pollution levels. We saw reference to that in the video. And then the final one is climate-linked migration and the impact on infrastructure. Okay, so let's start with the first one. This is a little bit of a deeper dive into the example that we just saw, the video, which was a focus study in India with operator called Airtel. And it was particularly looking at tuberculosis. And and this was done in, probably 2018 or 2019, 2018. So the World Health Organization, to put it into context, estimates that there were about 1.7 million deaths from tuberculosis globally in 2016, and 95% of those occurred in low and middle income countries. However, there were cases of drug-susceptible TB that could be treated through a course of antibiotics. A significant number of lives, I think 56 million lives, had been saved through a tuberculosis diagnosis and treatment. So this was focused on being able to identify people that had drug susceptible tuberculosis. So the background about TB is it's a bacteria that causes it, and it's spread from one person to another through tiny droplets that are released into the air via coughs and sneezes. And as a result, the frequency and duration of exposure to an infected person are two of the major factors that govern transmission of TB. So if you are exposed to somebody for a period of time, then you're more likely to be exposed to TB. So it's worth noting that the approach that we took in this proof of concept could be applied to any other outbreak of infectious disease. It just happened that for this project we were looking at tuberculosis. So the project started off by trying to identify whether regular population movement, so people moving from home to work, so the work commute, or the education commute, so basically habitual regular daily journeys, had a significant impact on the incidence of tuberculosis. And the objective was being able to provide the health authority with insight that could allow them to identify key locations in which to focus their anti-TB efforts, because as we know, resources are often limited. So we need to try and find solutions that can target efforts into the right place, and also potentially tackle under-reporting of the tuberculosis disease in parts of India. So if I go to the next slide, video. So I'll try and go quite quickly, but stop me if anything doesn't make sense. So first of all, we started by mapping the current disease distribution based on the reported TB cases. So we had some information from the Department for Health in India to look at where TB was being reported, and each state was divided into smaller areas which corresponded with the catchment area of a clinic. So each of these little areas, you can see, if you can see my pointer on the screen, were the clinic catchment areas. And then obviously the colours, red indicated a high TB rate, yellow a medium TB rate, and green was a low TB rate. So at this stage, there was no mobile data involved. We just looked at a map of India, a map of the reporting of TB incidents, and mapped it via catchment area. Okay, so then for the next stage, we use mobile operator data, and this was done by a data scientist to understand the population movements between the clinic catchment areas. So we looked at the movement of greatest interest were from the habitual movement. So sorry, let me explain that wrong. So what we wanted to look at was regular movements or habitual movements between one particular catchment area to another catchment area. So using aggregated and anonymised mobile data, it was possible to calculate the volumes of people that were commuting from one clinic area to another clinic area daily. And this type of analytical output that mobile operators create is often called an origin destination matrix. So where's the origin, where people start out in the morning, and where is the destination, where do they spend the daytime? And the output of this is a matrix of population flows from one area to another area. So as you can see on this screen here, we've got people moving from where they live to where they work. Okie dokie. So the movement patterns were then combined with data on TB incidence rates. And then this was used to create a visual picture of the movements and colour-coded by the TB incident rates of the clinic in the area where the people were travelling to for work. So the thickness of the line represents the volume of people moving between each pair of clinical areas. So a thick line means there are a lot of commuters moving from one area to another. So here, these lines were quite thick, so there were quite a lot of people commuting from here to here, either for work or for school. We didn't know, we just knew what time of day they were moving. So once you've aggregated the flows of people between one clinical area and another, this was modelled across the whole region. And then a second map was created, which showed where the models predicted that there could be a TB hotspot. So this was based on where there was regular movements of people from to an area where there was a high incidence of TB to areas where the reporting of TB was low. So I just explain here. So the areas with the purple border were areas where we identified that there were lots of people commuting into this area on a daily basis who lived in areas of a high TB rate. And that information was used to inform the health authorities that there's a potential that these people were either at higher risk of being exposed to TB, or actually there was potentially some underreporting of TB in that region. And what that information allowed then is decisions to be made. So for example, this could be then areas where there was a decision to put more TB testing into the region, or maybe a communication to the public, encouraging them to go along for look out for symptoms of TB and then go along to be tested. Public information notifications, that's what I was trying to think of the word. So this is how this was used. It was predicting where there could potentially be hotspots that weren't currently identified, and then allows the health authorities to make decisions about how they're going to respond to that. So that was the first example that we used, where we were looking for health hotspots. I'm going to move through the summary there because we're a bit limited for time now. We have 30 minutes. So the second, sorry, any questions about that too? Let me give the opportunity, because it is potentially a bit complicated, but hopefully the summary is that using population movement data, a particular type, which is an origin destination matrix, combining that with information that we have from the health authority about TB incidents, it is possible to make to identify patterns in that data that can then lead to interventions or decision making by the experts, which in this case would be the health organisation. Yeah, Feta, you've just said this operation takes a lot of time. It does. It absolutely does. Right through from starting with the raw data to cleaning all the data, removing all the noise and the bias, and then actually doing the analysis on the clean data to create those origin and destination matrices. So it does take time, but if you have experts in there that are familiar with the data and familiar with the process, that can remove error and can help it be as efficient as possible. And we'll go through some of those processes tomorrow in terms of what it takes to get from that list of loads and loads of lines of data through to understanding where TB may be a problem in India. But it's fantastic that we have this insight, but it does take work. Absolutely. And that actually also links to the need for sustainable business models, because of course this takes the time and the resources of probably not only mobile network operators, but potentially other third parties. For example, in this case, maybe the health authority providing the data in the first place, etc. So absolutely. Okay, so if we move to the next case, which is about applying mobile data insights to plan the interventions to limit the disease spread. Okay, so this is all a bit covert, but actually what we're talking about here is the COVID-19 virus, which I think we're all very familiar with. In 2020, COVID-19 rapidly spread around the world. And so this second example illustrates the role that mobility insight can and did play in response to the outbreak. Now, this is an example from COVID-19. It's an example taken from lots of different countries, but of course it could be applied to any infectious disease as well, not just COVID-19. So let's start here with just giving an example about the kind of support and decisions that need to be made when we have the outbreak of an infectious disease such as COVID-19. So this slide here shows the various stages in a pandemic and the kind of answers that you might want to have if you are a decision-making body through each of the stages. So you can see across the top, phase 1 to 3, this is where we start with few infections, then infections start to increase, then here we've got widespread infection, and then it's post-peak, but there might be some reoccurrence, and then finally we're at post-pandemic where it's becoming a seasonal issue rather than a big pandemic. So as we go through this phase of a pandemic, there are different types of questions that you might want to ask, that you might need answers to. So the first one might be, how do we prepare, protect and delay the spread? So how might the disease spread? So how can we respond? The next is around containing, responding and mitigating. So what measures need to be taken in order for us to mitigate the impact of the disease on the population? Then the third here, as we're looking towards the end of it, is how can we recover responsibly? How can we safely resume economic activity, for example? And then finally, all the way through, we're wanting to monitor and assess the situation. So this is potentially all of the areas where mobile data can support understanding. Excuse me. Lots of talking. So let's look at how mobile data analysis helps decision makers make decisions and get rapid visibility of their impact. And this here is a great example. So I think, as most of us know, in lots of countries around the world, one of the responses to COVID-19 was to ask the population to limit their movement. I think in lots of places it was called lockdown. People were asked to, in some cases, not leave their house at all, not go to work, work from home, only make essential trips to, for example, the supermarket, etc. So what this is showing is how you can use mobile network data to measure the response to government requests. So on the left here, we've got the population movement in a particular country. And so this is using mobile network data to look at the number of trips that are being made by people in a particular region per day. So the darker blue indicates, actually show here, the darker blue indicates the larger the number of movements that the population of that region are making on a daily basis. And then the lighter the colour is the fewer movements that they're making. And then the second map is taken after restrictions have been imposed. So here the government has said, in order to stop the spread of COVID-19, we'd like everybody to restrict their journeys to only essential journeys. And then this map, using population data movement, shows after the restrictions have been applied, how much movement has been made. And as you can see, all of the very dark blues have completely gone. We still have a few regions where there is more movement than others, but this can be, for example, this may be where a hospital is based, where people are going to work in the hospital, or may indicate a supermarket, for example. So, but overall, we can see that the total volume of population journeys across the population has significantly decreased. So that was one model that was being used, and I think that was used in quite a number of countries throughout the COVID-19 pandemic. And again, this data was anonymised and aggregated, so we weren't looking at if individuals were moving during the time. We were looking to see generally how the population was responding to the request to stay at home. Okay, the next one for COVID-19 was around a sort of dashboard. So this is about bringing to life some of the ways that mobile big data can be viewed and interpreted. So one of the ways is to create a visual tool to help provide the information to decision makers. And this is one example of a tool called a dashboard. So the element that makes up the dashboard illustrates that there are several different ways in which one set of analysed data can be viewed, and patterns can be identified that inform decisions and actions. So the example shown in this view of the dashboard is comparing data about movement of the population within a country for 2 time periods. So similarly to the information that we've seen on the previous slide. So it shows, excuse me. So it shows population movement in February, March 2020, so before the COVID pandemic, and then the second in March and April after the pandemic, where the first case had been detected, and people were restricted, people's movements were restricted. So I think this is here and here and here. So how can key patterns of movement before and after be understood? Well, the first way is to show movements on a map, like we saw on the previous slide, or the second is to show the population. Sorry, I think I've lost the thread here. Yeah, I'm sorry, and the second is to be shown in graphs. There we go. Okay, let me move on to the next one, because I think I'm duplicating a little bit given the time. Okay, so again, in summary here, when COVID-19 hit, it was new, highly infectious disease. There was a scramble to respond to that. One of the ways to do that was to enact a policy asking for movement to be restricted, and mobile population data, mobile network data can be used to inform decisions and also measure the impact of decisions afterwards. Okay. Right, okay, so there are a number of other things going on through COVID-19 that mobile and big data could be, was used to support. So, for example, giving you a couple of quick examples here. In one country, there was mobile big data was being used in order to predict where the infection may spread. And then that was used to be able to deploy resources to the regions where they expected would be hit by COVID-19 first, in terms of medical staff, test kits, hospital beds, that kind of thing. There was also prevention measures such as, public health communications and additional hand washing facilities, actually. So looking at infrastructure and population density and identifying where perhaps there was a lack of access to clean running water, and this would enable to identify places where we could drop in, where wash facilities could be dropped in to aid people to be able to regularly wash their hands, for the mobile big data was used to identify areas where economic activity had significantly reduced as a result of lockdown, and that was used in order to be able to deploy financial support solutions to the particular regions of the country that were most, very significantly impacted financially. Okay, so there are lots of different examples through COVID-19. Okay, so if we move to the next one, use case 3 is about responding quickly and effectively to natural disasters. So system support can support decision making in live disaster scenarios with the aim of improving efficiency of the response by doing things like improving and facilitating coordinations between agencies that respond to natural disasters, integrating information from multiple sources, and incorporating AI-based suggestions into the interface. So if we take a little bit more of a closer look at this, so mobile big data analytics and AI can be used for disaster preparedness, including addressing challenges that arise from floods, droughts, volcanic activity, nuclear emergencies, for example. And the use of the mobile data analytics and AI products can be used to prevent and respond and recover from, as well as mitigate the repercussions of the disasters. In some places, destructive natural disasters regularly threaten the population and infrastructure of major cities. We see often on the news that certain locations are regularly hit by natural disasters, and of course this costs lives and it damages the economy, and so there's a real need to respond to these events faster and in a more cost-efficient way to help save lives and prevent as much damage as possible. So in this example, 3 companies came together to collaborate on a project that took information from sensors, so the Internet of Things, we talked about Internet of Things earlier, devices and mobile networks, and fed all of that into an AI system. And this helped produce a decision support system that helped the government to respond quickly and efficiently when a disaster occurred. So if we deep dive into this a little bit more, so the output of it was a decision support system that pulled information from several sources. And so, for example, it can take mobile phone data and combine it with data from information probes, hazard lamps and sensors that measure things like the outdoor temperature, anonymise it all, and then provide a guide to traffic flows during in an evacuation, for example. So if we're trying to move a large volume of people, it can help to plan how to deal with those traffic flows. It can also use the information along with data such as seismographs, water level monitoring, slope indicators to make predictions about whether evacuation might be required. So if I look at the next slide, I think it goes into a bit more detail. Yes, great. So this looks at the data feeds that fed into this decision support system and where the particular data came from. So first of all, we've got the IoT sensor we mentioned. So these are sensors that are in the environment, and they can look at things like ground saturation. So we could help to understand if there was rain or floods, whether the water could dissipate swiftly enough, water levels in things like rivers, and streams and lakes, and then the weather. So, is it raining? Are the water levels high? Is the ground already saturated? And is it raining a lot? For example, this could be the kind of information that we might see from an IoT sensor. The next is external APIs. So this is about understanding, gathering information from third parties. So, for example, topography. So understanding the land more. And the next is weather. So, for example, weather forecasts, and understanding if we're expecting to receive rain for the next 3 or 4 days, for example. The next one is, jumping ahead. The next one is connected cars, which provides data on the status of the road network, providing information such as the speed of motion, so how fast are people moving away, whether hazard lamps are being used, so are there road conditions difficult. And then, of course, the mobile data, which can identify the number of people occupying different parts of the landscape and allowing the system to detect gatherings of large numbers of people who might be in danger. So combining all of these data sources into a single picture can provide a powerful insight into the live situation and opens up possibilities that wouldn't be available using fewer sources of data. So having a live understanding of the situation can help you make better decisions more quickly about how to prevent risk to life of the population. Okay, so to summarise on this one, this decision support system demonstrated how big data can accelerate a government's ability to implement disaster prevention measures, such as traffic regulation, evacuation warnings, and on-site safety information. In comparison with existing response capabilities that we have today, the service can seamlessly combine data from a wide range of sources to provide powerful insights that enable emergency services to take action and significantly reduce the response times. It can intelligently process information in real time, enabling government to flag potentially hazardous situations and take preemptive action that can save lives. And it can markedly reduce the risk of government underestimating the severity of a disaster, ensuring that the most vulnerable civilians in emergencies are given the right relief supplies to survive. And it can enable local administrations to provide citizens with critical guidance of when evacuations become absolutely necessary. I think that example was in Japan, but I'm not 100% sure. I didn't work on that one directly. So the fourth, okay, let me see which one we've got. I think we might just have time. Yeah, we'll have time for both of them, I think. So very briefly, and actually this example was shown in the video, so I'll be quite brief about this one. Even though I love this example, it's a great use case of how air pollution can impact health. So this was a project that was done by Telefonica in Sao Paulo. Sao Paulo has very high levels of pollution, and they wanted to use mobile network data combined with other third-party data to understand the pollution situation and get to a position where they could predict what pollution levels might be in certain parts of the city. So the situation was that they did have some traffic sensors and they had some pollution sensors deployed around the city, but they're quite expensive to deploy, and they was static, so they could only identify very specific location. But we could take that data and then also take the mobile network traffic, the population movement, to be able to use that as a proxy for traffic movement across the city. And that was used then to model carbon dioxide emissions across the city. And it was identified that there was a strong agreement between the carbon dioxide emissions and the population movement. So this indicated that using mobile data served as a good proxy to identify carbon dioxide emissions. So that was the first step. And then the mobile positioning data, which was being used as a proxy for the traffic movement, was then combined with other data, including weather data, so current weather data and weather forecasts, and historic air quality data. And that was fed into a machine learning model to be able to then generate the air quality predictions. So using the current status of the environment and traffic population information, it was able to generate a prediction of what air quality levels were going to be like in various parts of the city. Okay, so the summary for this was that mobile big data was a powerful tool to predict and analyse traffic patterns, and as a result, air pollution across the whole city. Mobile data, it enabled a more granular monitoring of air quality than could be realised through the network of the static sensors that are very costly to deploy and maintain. And so this example highlights how mobile network data correlated with the air quality, the weather and the other sources to help predict pollution in advance. And of course, the benefit of being able to predict the air pollution in advance is it gives local authorities the opportunity to take preventative steps to prevent emissions from endangering human health. So the type of response could depend on the decisions wanted to be taken by the local authority, but examples could be reducing the number of vehicles that were allowed into the city or parts of the city on days where pollution was predicted to be very high, or it could be simply around notifying the population that the air quality is going to be poor the next day, so to avoid moving into the city, or to wear a mask or something like that. And I think that the output of this was it was able to predict the air pollution within the city up to 48 hours in advance. So, giving the local authority a lot of information for which to make decisions. And of course, that kind of modelling could also be used to make longer term models. So, for example, identifying particular regions that were particularly susceptible to high levels of pollution, and maybe influencing future decisions about where to locate new car parks and or traffic calming schemes and that kind of thing. Okay, right, we're nearly at time, but we are at the last example. So I'll just briefly talk about climate-linked immigration and the impact of infrastructure. So this fifth use case is referring to migration that's driven by extreme changes in climate. And as we know, this is becoming a world crisis. In 2017, around 90 million people across 135 countries were displaced from their homes, forced to move elsewhere in the country in order to survive. And in the last decade, estimates suggest that around 25.5 million people have been displaced internally due to natural disasters. So this example from Latin America is showing how mobile data is enabling policymakers and agencies to understand where people are moving to and from, and then that enables governments to make sure that they're making better decisions to mitigate the economic and social impact of these displacements and helping to build more resilient communities. So the project started by using climate data to understand vulnerable areas. And once he'd established the areas to examine, it took anonymised call detail records and combined these with open data sets to produce insight into people's movements in response to the climate extremes. So unlike the disease outbreak, the aggregated population movements in this case were over a much longer period of time. So we may be looking over months or years. Hi, was that a question? No. Okay. If you could go on mute for the last couple of minutes, that would be great. Thank you. So yes, this example is taken over a much longer time. So in terms of the COVID-19, for example, we may have been looking at, we wanted to know the population movement, number of population journeys within a day. In this case, we're wanting to look at people's origins and destination movements over weeks or months, for example. So mobile analysis helps us to understand whether this is a temporary displacement or a permanent change in where people live. And the project was modelled where people started from and where they moved to. And then that was used to plan where the resources were needed, for example, schools and health facilities, for example. So yeah, I think that was the last example there. Let me move to the quick quiz. Let's go to the quick quiz to see how everybody's feeling about this. And then I think this is the last slide for me for today. There may be one actual other set of questions. Let's come to that. So if you do have any final questions, gone right up to the time, haven't we? So in terms of mobile big data analytics, what do we think is it useful for? Is it useful for fighting epidemics? All of the above there. Krishna's jumped straight to the question. Thank you. Yeah, all of the above. You're absolutely right. So mobile big data analytics is great for fighting epidemics, combating pollution, responding to natural disasters, and planning for internal migration of the population. So it can be used for all of these things. But as I said at the beginning, it's not limited to this. And the benefit of this kind of data is once this raw data has been cleaned and processed, it can be potentially combined with any other kind of data in order to provide the insights to affect positive decision making. So, yes, there was no more questions. So this was the end of day one. We've got tomorrow, we will be looking at a little bit more in detail at how we do all of that processing and talking about the anonymisation and aggregation of the data. And then in the second part, we'll be looking at some of the policy, regulation and the ethics around AI. And the sustainable business models. So I hope that you found that helpful. My voice is just about ready for a rest, but do we have any questions or any more questions before we close the call today? Great stuff. No questions. Thank you very much. Andrea, anything for you before we close, or do we just need to say thank you everybody for joining, and we look forward to seeing you at the same time tomorrow for the second part?
Yes, thank you, Joe, for joining today, for your fantastic presentation, and all for joining. Just to remind you that in order to complete the course, you need to participate during these 2 days and answer a short quiz I will be sharing with you tomorrow. But we hope that you have enjoyed this session today, and we hope to see you tomorrow as well. So thank you very much. And if you have any questions in the meantime, you can write us an email, and we hope to see you tomorrow, to all of you. Thank you very much, and bye-bye, Joe. Bye, everyone.
Thanks, Andrea. Thanks, everyone. See you all tomorrow.
Bye-bye.
See you tomorrow. Bye.
Bye, everyone.
Thank you. Bye.
Bye.
See you tomorrow.